This is Geometry, Chapter 1, Section 6, in which we will be discussing two-dimensional figures. First term we need to learn about is what we call a polygon. All a polygon is a closed figure formed of a given number of coplanar segments. Those segments we call sides. You've been dealing with polygons for a long time. Triangles, rectangles, squares, hexagons, octagons. Okay, you've got polygons all over the place. The rules are the sides have to have common endpoints. They have to intersect exactly two other sides, and they can't intersect anywhere but their endpoints. And I'll show you later on what that's getting at. But they have to close up, and they have to go corner to corner. They can't cross anywhere else. Now, polygons have two choices. They can be concave or convex. And the way to tell the difference is extend the sides. If the sides, when you draw the lines further out, if they go through the inside, then it's concave. If not, it's convex. And I'll show you a picture of that here coming up. The way we name polygons is based on their sides, how many of them they have. You're going to want to have this list handy when you're doing problems. So make sure you do a good job of taking notes here. If it has three sides, you already know the name of that. It's a triangle. Four sides is a quadrilateral. Quad meaning four. Lateral meaning side. Yes, I know you probably thought, oh, rectangle. Well, that's a special kind. Or square, that's a special kind. Five-sided is a pentagon. Six is a hexagon. Seven is heptagon. Yes, I know I'm going faster than you can write, but when I get the whole thing cleared out, you can pause the video and jot them all down. 8 is the octagon. 9 is a nonagon. 10 is a decagon. 11 is a hendecagon. 12 is a dodecagon. And anything over 12, any n number of sides, we just call an n-gon. So for example, 20 would be a 20-gon. 30 would be a 30-gon. So what I would recommend you do here is pause, get those written down so you have them handy, and then come back and we will proceed. Okay. A polygon that has all of its sides congruent is called equilateral. You can see it right there in it. Equal, lateral meaning side, so equal sides. And it's called equiangular if all of the angles are congruent. And if it meets both descriptions, it's equilateral and equiangular, and it's also convex, then it's called a regular polygon. So they're going to give us some polygons and ask us to name it, decide if it's concave or convex, and decide if it's regular or irregular. Well, let's try the first one here. 1, 2, 3, 4, 5, 6 sides. Go back to our trusty chart from the last page, and we find out 6 sides is a hexagon. Now, all the sides are equal. Oh, jumping ahead of myself. Is it concave or is it convex? Well, if I extend this side I go through the inside of the picture, right? If I take and extend this side, I've gone through the interior. So that is not convex, it is concave. Okay. And then we have to decide if it's regular or not. Well, they've marked all the sides to be equal, but the angles are not all equal. We've got two sets equal, but not all of them. And besides the fact it's not even convex, so that one is irregular. Okay. Then we've got this guy. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. On our trusty chart, 11 sides is a hendecagon. Is it convex or concave? Well, if I extend any of the lines, they go on the outside, so it's convex. All the sides are equal, and it says all the angles are equal. They're all marked to be equal. So this is a regular hendecagon. Okay. Now we're going to get into some of the things that you've been doing since 2nd, 3rd, 4th grade. When we have a polygon and we add up the lengths of all the sides, what we have found is the perimeter. It's the measure around everything. Now, if we're not dealing with a polygon, we're dealing with a circle instead, then it's not called the perimeter, it's called the circumference. And there are two different formulas for circumference. You could either use 2 pi r for circumference, or you can use pi d, depending on whether you know the radius or the diameter. Now, if we want to know how many square units it takes to cover the interior, that's called the area of the figure. And each type of figure has its own formula. For a rectangle, it's length times width. Probably already knew that. For a triangle, it's 1/2 the base times the height. And for a circle, area is pi times the radius squared. Okay. So some things you probably already knew, but it doesn't hurt to refresh your memory. And then our final slide, we're going to find values for perimeter and circumference, perimeter or circumference, and then area for each figure. So we need to decide what we're looking at first. We're looking at a rectangle. Well, the perimeter is add up all the sides. 6 plus 4 plus 6 plus 4, which is 20 feet. If they give you units in the problem, you have to give units in your answer. I'm going to say that again because it's important. People will get this wrong and they'll be upset that they got things wrong. If they told you units in the problem, then you have to use units in your answer. They told me feet, I need feet. Area is length times width. 6 times 4, which is 24 square feet. Feet times feet is feet square. Let's tangle with our circle here. We have a circle, and we have a radius of 3 inches. Since we have a radius, we're going to use 2 pi r. 2 times, we know a value for pi, 3.14. R is 3. If you multiply that out, you get 18.84 inches. Now, if you used on your calculator the pi button, you'll get a little bit of a different answer, but you'll be close enough that it's okay. I'm not going to tell you you always have to use 3.14. If you've got a pi button, you want to use pi as the pi button, go for it. Area for a circle is pi r squared, which is odd because every pie I've ever made is round. They're not square at all, but that's beside the point. Well, area then would be 3.14 times 3 squared, which my calculator tells me is 28.26 square inches. And again, you might have a little different answer if you dealt with the pi button instead of 3.14. And that's fine. Finally, we have our triangle to deal with. The perimeter of the triangle is add up the sides. 9.5 plus 9.5 plus 10.2 is 29.2 centimeters. Area, we said, is 1/2 times base times height. Well, the base is 10.2 and the height is 8. Punching that in, we get 40.8 square centimeters. And as always, if you had questions, hope you jotted those down. We went through area and perimeter and circumference. We went through naming figures and deciding if they're concave, convex, and regular or irregular. If you had questions on any of that, I hope you jotted it down on your handy note sheet. And we will see you in class.